In 5.1 Part B, we will be finding coordinates given slope and finding rate of change. For example, 5, we're starting with 5 because we are continuing lesson 5.1. Find the value of r so that the line through 6.1 and r2 has a slope, we use m for slope, of 1/2. Trying to fix my 2. It's looking like a blob. Let's fix the 2. Okay, so I'm plugging into the formula again. This time I know m to start with. That's different. Okay, so 1/2 equals change in y, so 2 minus 3 over change in x, r minus 6. I know what 2 minus 3 is, so let's simplify as much as we can. So we have 1 over 2 equals negative 1 over, I'm stuck with r minus 6. What I can do, cross products, numerator times denominator. Oh, I like multiplying by 1, it's great. So we have 1 times r minus 6 equals 2 times negative 1. Come up here, so distribute the 1, not much happens when we multiply by 1. This is a nice one to start with. And if I add 6 to both sides, I get r equals 4. I think we should do another one like that. This time our slope is more interesting, negative 5/8. And we're going to have negative 1 minus 4 for a change in y, and 3 minus p for a change in x. Okay, so I have negative 5 over 8 equals negative 5 over, oh, for pity's sakes, 3 minus p. Okay, I'm saying for pity's sakes because they're both 5s, but we're going to go ahead and do it anyway, like we didn't know where it was going. Okay, so if I had to do cross products, I'd have negative 5 times 3 minus p equals 8 times negative 5. So negative 15 plus 5p equals negative 40. Add 15 to both sides. So I have 5p equals negative 25, divide by 5, and p is negative 5. And go ahead and pause if you need to copy it if I went too fast, and we're going to go on to rate of change. Slope can be used to describe a rate of change. The rate of change tells, on average, how a quantity is changing over time. The graph to the right shows the number of U.S. passports issued in 1991, 95, and 99. Find the rates of change for the years 91 to 95 and 1995 to 1999. So in example 6, they're really giving us 2 rate of change problems to do. So like we did 2 for example 5, we're going to do 2 for example 6. It's just all in 6. Okay, rise over run, and this time is change in quantity, so change in millions of passports over change in time. So in 1995, there were 5.3. In 1991, there were 3.4. So we could kind of have 2 ordered pairs right there. So our independent variable is going to be the years. So 95 was 5.3, and 91 was 3.4. So then we have our change in y, 5.3 minus 3.4 over change in x, 1995 minus 1991. Now writing the 19s down this time was really kind of irrelevant because they're going to drop out anyway. It's going to be a difference of 4 years. And 5.3 minus 3.4 is 1.9. Divided by 4, we get a rate of change of 4.75. And we have to remember what our units were. Okay, so when we do the rate of change from 95 to 99, we did change in y, so 6.7 minus 5.3 over change in x, 1999 minus 1995. So that's 1.4 divided by 4 using a calculator. We got 0.35. Okay, now we get our units in here. So because our units were in millions of passports, the first rate of change translates to 475,000 more passports each year than last. And in the 1995 to 99, it was an average of, so 0.35, since it's in millions, translates to 350,000 more passports each year than the year before. How are different rates of change shown on the graph? There is a greater rate of change from 91 to 95 than from 95 to 99. Therefore, that section is steeper. So rate of change is really just a special case of slope, and it is amount change divided by time.